Welcome everyone. This is lecture number 2 of Unit 3. In this lecture, we are going to cover the topics keyboard keys and the keyboard interface. In keyboard keys, you will know about the types of keyboard keys which are available and how the keyboards are connected with the computer system, that is keyboard interface. So starting with what are switches. Actually, the keyboard switch is a main visible switch, or you can say main visible component of the keyboard. These switches convert our typing action into a proper signal for the keyboard interface, so that interface will know that a key is being pressed. The section which we are going to cover is type of switch, means what are the types of switches that are available in the different types of keyboard. So here you can see the picture of a simple key on a keyboard. When we press this, then the proper action, or you can say the typing action, will be converted into proper signal for the keyboard interface, and that then it will be given to the CPU. Now the types of switches. Among the types of switches is first is membrane switch. So a membrane switch is an electrical switch for turning a circuit on and off. The membrane switch is appearing like this. It is like a board on which the numbers and characters are printed, and it is mostly in very small size, and this is the matrix that is available. That is, matrix is small compared to the computer personal desktop keyboards. A member switch is a printed circuit on polyethylene terephthalate or indium tin oxide. The ink used for screen printing is copper, silver, graphite filled. The membrane switches can be thought of as one category of interface utilities alongside touchscreen, plastic keyboards, toggle switches, and many other kinds of control system. These keyboards are nothing but these are touch screens and made up of plastics. So these are known as plastic keyboards, which are having toggle switches. So you can see here the membrane switches are made up of 4 layers. First of all, top layer, it is also known as panel layer, which is having graphical interface. Then second layer will be a conductive pad. It is also known as conductive layer, or it is also known as shorting pad. And it can be a shorting pad or a metal dome. So basically it is made up of metal, and if it is dome, then it will be standing on legs like this. So next is conductive track. These 2 points are conductive track. You can also see here, this is another printed circuit board, or you can say it is another circuit. This is nothing but it is a conductive track, and another critical layer is printed circuit. This green one and here blue one is printed circuit board, where actually if you press a key, then the information which is to be sent to the keyboard interface is printed on this PCB. So whenever you strike a key down, then this switch will come in contact with this PCB contacts, and finally a circuit is shorted, or you can say a circuit is completed, and the information is sent to the keyboard interface. What is the use of membrane switch? A membrane switch are used in number of applications, including medical, aerospace, defense, industrial, and transport industries where a control panels are available. Like a plant, or you can say chemical plant, there are a number of control panels, and these control panels are having these kind of membrane switches, and they are often used for keypads, control panels in aircrafts, touchscreen phones, and kidney dialysis machines. These are just to name a few of the membrane switch. What are the properties of membrane switch? Means membrane switch are durable and flexible, especially in high or low temperature environment, and it is also reliable and highly conductive. Types of membrane switch. There are two types of membrane switch. First is tactile and second one is non-tactile. So tactile, you can see the first layer is also known as overlay. It is also known as panel layer. And you can see in tactile there is a dome. This is a metal dome. So main difference between non-tactile and tactile is having dome, while non-tactile is not having any dome. It is having conductive pad. Um, so whenever a key is pressed, the dome will be seen like this. Uh, there is a dome in tactile and conductive pad in non-tactile. So whenever a key is pressed, the dome will be seen like this, and conductive pad, as it is straight, so it will remain straight. So when key is pressed, the dome is this point is will be touched to this PCB contact, and the circuit is shorted and the key is finally pressed and information will be sent to keyboard controller. While in non-tactile, simply conductive pad will touch these two conductive track, and finally circuit is sorted and the information is sent to the keyboard controller. Next is mechanical switch. A mechanical keyboard is a mechanism called a switch that registers the keystroke. These switches have a variety of response like noise and travel times, and which makes them attractive to gamers, coders, or typists. Means it creates some kind of noise, or means it nothing but it creates some kind of response, so that a user feels some kind of lively or responding environment while using the keyboard. So some keys give you tactile feedback. Tactile feedback means whenever you press something, it will feel like you are pressing something, you are inserting your finger somewhere, so somewhere on the key. So this is the tactile feedback. This makes typing easier on the fingers, and some gives audio feedback or uniquely clicky sound. This feedbacks help you to recognize a key press. Now these are the components of mechanical switch. First one is keycap, second one is stem, third one is upper housing, fourth one is spring, or you can say coil spring, and fifth one is the base housing, and the last one is sixth, that is cross point contact, that will be in directly contact to the PCB, that is circuit of the keyboard. You can say keyboard controller. So the keycap is nothing but it is partially the part of keyboard, uh, partial, or you can say partially responsible for the noise generated when the key is bottomed out. Means you are pressing, and whenever it is coming back to its position, there is a noise, and this is partially responsible for that. Second one is stem. The shape of the stem varies the actuation and travel distance of the switch. It creates the keystroke feel and determines the switch type. Means this is used to feel, or you can say feel the keystroke whenever you are pressing to this. This is the part of actual key, and there is a upper housing that guides the stem. It is also the part of keycap. It's when you press the key. Means when you press the key, the keycap also touches this one. Second one is coil spring. Fourth one is coil spring. The resistance of coil spring determines the amount of pressure need to actuate the key. it also guides the switch to slide back. Means when you are pressing this key, so with the help of spring, the key will come to its original position with the help of this spring. So basically the function of this spring is to guide the whole switch to come back to its original position after pressing it. The base house is where the whole unit is mounted. This is the piece that attaches and clips to PCB, means it is clipped. It is attached, or you can say it is fixed on PCB. The cross point contact, this is nothing but it is a tiny metal, or you can say gold piece, where the electricity flows. Once you press the key, the contact mechanism hits the PCB, means process control board. It hits the PCB and closes the circuit. Means when you press this, it will automatically press the stem. Then then this stem will press the upper housing, and both of this unit will be pressed upon spring, and the spring is housed on fifth, that is lower, or you can say base housing. This whole unit is housed on this house, means it is mounted on the base housing, and this helps the whole unit 2 and 3 to come back into its original position. And fifth one is linked to the sixth one. Sixth one is nothing but cross point. It is linked with the PCB, it is keyboard controller, and when we press all these things, it flows a current, and thus it creates a short circuit, and it determines that a key is pressed. Now the types of mechanical switch, there are three types of mechanical switch: linear, tactile, and clicky. So whenever any click sound is heard after pressing a key, then these kinds of switch is known as clicky mechanical switch. And if there is any bump in the switch below the switch, then it will be known as tactile, and if there is no bump, then it will be known as linear. Now you can see here the working of three switches. This is linear, there will be no bump here. In this there will be a small bump, and this one is clicky. This is the part which creates the sound, or you can say creates the noise, or you can say responding with the noise. So this is known as clicky. It creates a click sound when you press it. Next one is rubber dome. So rubber dome switches are very common. They usually, or you can say, there is a flexible rubber domes with each hard carbon center. These are the carbon center, and these are the rubber dome which are attached to each carbon center, using collapsible rubber domes to provide resistance and tactility to keys. Where all the domes are formed from a single sheet of a plastic, they can be referred to as rubber sheet keyboards. In these keyboards are also known as rubber sheet keyboards. In most cases, these days keyboards will be rubber dome over membrane. This is a membrane and this is a rubber dome, and then there is a carbon center. So what is the mechanism of rubber dome? When you press a key, a plunger on the bottom of the key pushes down against the dome, and the carbon center presses against a hard flat surface beneath the key matrix. As long as the key is held, the carbon center completes the circuit. Means when you press the key, the carbon center will come in contact with that thin sheet, and then thin sheet will just complete the circuit. When the key is released, the rubber dome springs back to its original shape and forcing the key back up to its at rest position. Rubber dome switch keyboards are inexpensive, have pretty good tactile response, and are fairly resistant to spills and corrosion because of the rubber layer covering the key matrix, key matrix is covered with this rubber layer, so it is resistant to water. Spills means some kind of water, and corrosion means corroded with corrosion of the metal exists every time, so it also prevents from. So you can see when you press this rubber dome, it is pressed and it comes to its original position, and when it is pressed, the carbon is heated and carbon just touches the sheet, and this sheet is nothing but a printed circuit board, and then the particular signal is sent to the CPU with the help of keyboard controller. These are the types of rubber dome. You can see this is a sheet having all rubber domes on a same sheet, membrane sheet, and this is apple design. Individual rubber dome is there, then loose rubber domes are there, contiguous sheets of domes, scissor. You can see here it is whenever you press this, it appears like a scissor. Then Alps integrated rubber dome. This is a Alp, this is integrated in this, and there is a rubber dome on this. So these are the types of rubber. Second, next is capacitive switch. Capacitive keyboards work primarily by detecting the change in capacitance on the capacitor pad spread across the whole keyboard. Unlike traditional keyboards where electricity flow initiates internally when a key is pressed, electricity is always flowing in capacitive board. Means in traditionally the electricity flow is initiated or it is started when a key is pressed, but in this capacitive switch electricity is already flowing, but with the change in capacitance the keyboard key hit is recognized. Under each key, static charges are stored in capacitors. So when a key is pressed, it connects with the capacitor and changes the capacitance at the specific point which the keyboard identifies and registers at the exact keystroke or key. Capacitive keyboards are faster than contact keyboards as they only require a gentle push to register a keystroke. Now, what are the interfaces of keyboards? So we have already studied the interface in Unit 1. A wired interface is PS2, then USB and serial port. Serial port DB9 and DB25 COM port. These serial ports are used to connect the keyboard. These serial ports were the initially these ports were available to connect the keyboard, but as time evolved, then PS2 arrived, and after that nowadays USB keyboards are available. And another interface is wireless interface, Bluetooth, infrared, and radio frequency are the types of wireless interface. So the Bluetooth keyboards use a Bluetooth technology which provides greater range than the radio frequency, and the infrared keyboards are to be kept in the line of sight of the receiver. Basically, wireless interface works on receiver and transmitter concept. So we need to keep the receiver in the line of transmitter, and then you can connect your keyboard. Then radio frequency keyboard get the required power from batteries or have an USB cable to charge the keyboard. The radio frequency keyboard provides a greater range than the infrared keyboards. The radio frequency keyboards offer a great mobility than the Bluetooth and infrared keyboards. Great mobility means you can move your keyboards uh, more farther from the computer compared to the Bluetooth and infrared keyboards. Here are the references, and for more videos, you can just go to my YouTube channel and find other videos of the same unit and other units of the same subject. Thank you very much.